Algebra 1 students, welcome to today's lesson. We're going to take a look at exponents. Specifically, we're going to be talking about what it means when an exponent is 0 or when it's negative. I know some of you are probably jamming to the tunes right now, but let's do some math. So here we go. First, a definition. An exponent is a mathematical operator that indicates repeated multiplication. You've seen this before. The example x cubed would be x times x. Now let's go ahead and fill out this chart. Some of these you'll already know. They're pretty basic ideas. Ones like 2 to the first, well, that's just simply 2. 2 to the second would be 4. 2 to the third, 8. That's again 2 times 2 times 2. And if we went one more step, 2 to the fourth is 16. I like to start with this side of it because we have to talk about the relationship here and why we end up with the numbers we end up over here. So let's take a look at the pattern. We knew to go from one number to the next, we were multiplying by 2. Now if we thought of it in the opposite direction, what are we doing? Well, to go from here to here, we're dividing by 2. Same thing to go from 8 to 4, dividing by 2. And of course from 4 to 2, same idea. We see a pattern. So I bet some of you are figuring out, hey, we'll probably continue that pattern, and you would be correct. So if you take 2 and you divide by 2, you get 1. As a matter of fact, we'll look at this more in a moment, but any number to the 0 power is exactly 1. So what I'll do now is continue that pattern of division by 2. So I know 1 divided by 2 is 1/2. 1/2 divided by 2. Now some of you are stretching your brains a little bit here, but 1/4. 1/4 divided by 2, 1/8, and 1/8 divided by 2 is 1/16. You might take a minute and look at how numbers like, say, 2 to the negative 2 and 2 to the positive 2 compare. You could do the same thing with 2 to the negative 3 or positive 3. Lots of patterns for you to pick up on and consider. Now here are two of the big ones. X to the 0, any number x to the 0 power is equal to 1. I should point out there's one exception to this. X cannot equal 0. You end up with weird stuff going on there. So we will not have that happen. And then the other one is this, x to the negative a. We saw that earlier with 2 to the negative 1, negative 2, negative 3, etc. is the same as the reciprocal of the reciprocal of x to the a, so 1 over x to the a. These two relationships are really what we're focusing on today. If you know these two things, you will be in great shape. All right, so let's take a look at this. Some of these will be fast, some take a little more thought. This would be a fast one. 7 to the 0 is just like any other number to the 0. It's exactly 1. 7 to the negative 1 is the same, and I'm going to show you an in-between step. You would definitely not need to do this on your own work, but that's the same as the reciprocal of 1 over 7 to the first, or just simply, and this is what you would need, 1/7. Okay, we could do the same thing with 7 to the negative 2. That's 1 divided by 7 squared, or as we know that, 1/49. All right, now sometimes we'll get negative numbers. We have to be really careful with order of operations here. Do remember that when we talk order of operations, we know that exponents happen before addition or subtraction. Okay, so what I need to do is consider that negative just to be its own thing. I'm going to leave that out in front. 10 squared is 100, so negative 10 squared is negative 100. Keep in mind that's different than a negative 10 quantity squared, which you'll see problems like that in just a moment. Same consideration here, negative 10 to the 0. The negative, we just keep it separate. 10 to the 0 is 1, so this is exactly negative 1. All right, so why don't you guys give these four a shot, pause the video, and then compare your answers to mine after you have them done. All right, welcome back. Take a moment and compare your answers to mine. One thing I really want to point out are numbers 6 and 7. You'll notice on 6 and 7, it's really the same number, negative 10 to the negative 2. The difference being on 6, it's just a negative 10 to the negative 2, where on 7, the negative 10 is in parentheses. Those parentheses tell us we're actually applying the exponent to the entire term. And so I could actually write like an in-between step here. This is the same as doing 1 over, and then that's negative 10 quantity squared. And I'll erase this and actually line it up a little better. We know negative 10 times negative 10 is a positive number, so that's 1/100th. All right, again, you can see 8 and 9. If you have questions, bring them to class. All right, let's take a look at the next few examples. This time we're going to throw some variables into the mix because we thought the numbers were too simple. So here we go. 5 times x to the 0 times y. Here's the only thing we have to do with this one. We know that x to the 0 is exactly 1. Okay? So that means 5 times 1 times y. This is 5y. The x is just gone. All right, similar ideas on number 11. Let's simplify this piece by piece. 7 to the 0 we know is 1. A to the negative 5th is the same as the reciprocal, so 1 over a to the 5th. So I'm just going to move that negative exponent to the denominator. B to the 4th, can't do anything with that. We'll leave it right here, b to the 4th. Okay, let's go to the denominator. 3 to the negative 2. Okay, that is where we would move that up to the numerator. I'm actually going to delete that one. We don't need it anymore anyway. So that would be 3 squared up there. C to the 3rd stays exactly where it is because it's a positive exponent. D has a negative exponent, so I'm going to switch it to the other side of the fraction and change it to a positive. We always want positive exponents with these. Our last job here is to go ahead and simplify. There's only really one thing we can do with this. 3 squared we know is 9, so we're going to rewrite this as 9b to the 4th d squared divided by a to the 5th c cubed. I know there's a lot going on that one. You have 1, 2, 3, 4, 5, 6 separate terms being simplified individually. But I've got 2 of them for you on 12 and 13 that I want you to do on your own, and they're much simpler. Again, pause the video, then compare your answers to mine. All right, you can see my answers now on 12 and 13. On 12, essentially the x had to move to the other side of the fraction, and on 13 we just again had to move the x. In both cases it was negative 4, so in this case that moves to the numerator, in this case it moves to the denominator. Alright, so now we're going to continue with the same process, but instead of just working with variables, we're going to plug in some numbers. I don't know that this is anything too crazy, but let's try it and see how you do. So r to the negative 3, where we know the r value is 2, we're just going to plug in 2. And then we know that 2 to the negative 3rd is the same as 1 over 2 cubed, or the reciprocal of 2 cubed. And then that, of course, is 1/8. Pretty basic idea. Okay, you got to be careful on 15. This is one of them. I see a lot of mistakes, and people come and say, Mr. Hale, I punched in my calculator, and it told me the answer, and you're wrong. Well, that's never true, of course, as we know. But I'll go ahead and show you why. All right, so s squared. We know that s is negative 4. You'll notice in the original problem that we're squaring s, not just part of s, all of s. And s is a negative number. That means we're squaring the entire term s, and negative 4 times negative 4 is 16. All right, pause the video. Do 16 and 17 on your own as you enjoy this announcement, but via the Olathe South Intercom. All right, welcome back. Take a look at what I did on 16 and 17. I want to point out a slight difference. I approached these two a little bit different way from each other. So on 16, you'll notice I immediately went and plugged in my value for r, and I plugged in my value for s. After I plugged it in, I realized, okay, this negative 4 has a negative exponent. I've got to move it to the numerator. So I got 2 times 2 squared times negative 4 to the 1st, which was negative 32. Now on 17, I took a different approach. Rather than plugging in numbers immediately, I first simplified the variables. In other words, that r to the negative 3, I didn't want it in the numerator anymore, so I moved it and made it an r cubed in the denominator, then substituted in my values for s and for r. Negative 3 times negative 4 gives the positive 12. 2 cubed is 8, and 12/8, of course, is 3/2. All right, folks, that wraps up our notes for today. I hope this makes sense to you. You know the way this works. Come into class. Next time we see you, you're going to come in and get to work. If you have questions on the notes or on any part of the assignment, please, please, please ask them. And you guys have a lovely day.